Hello, everyone. My name is Peter Prevelo-Fodu, and I will be taking you on the topic reflection of light in a physics class today. I want you to get your notes ready and be ready to pay rapt attention, as I'll be discussing concepts that are important for your examination and also generally important for your physics knowledge. So please pay attention as I share the board now and we begin class. So again, I repeat, the topic of consideration today is reflection of light. So the first question that comes to mind is, what is reflection of light? What is reflection of light? This is a possible exam question, and you can define reflection as reflection of light is the bouncing back of light rays from the source when it hits a surface. It's the bouncing back of light rays which are coming from the source when they hit a surface. Or we can say it is the return of light rays back to the source plane after hitting a surface. So the idea here is, we can paint that idea with a diagram and say, okay, let's say we have a source. This is the source. I'm going to call it the source plane. And then we have another surface, which I can call a plane mirror. If light comes from this source, the idea of reflection occurs when it bounces back to the source plane. So we call this incident ray, and we call this reflected ray. Please take notes and listen attentively. Normally, in the concept of reflection, we have something called the normal. And that is like the angle 90 with regards to the surface. That is like the perpendicular line to the surface of reflection. So this is the normal. We call that the normal. Take note of that, please. And so the angle that the incident ray makes with the normal is called incident angle or angle of incidence. And we denote that with I. Then the angle that the reflected ray makes with the normal, we call that reflected angle or angle of reflection. Take note of that. So some important concepts that we will define as we go further in this topic are: number one, plane mirror. So we can call this the highly polished surface polished and smooth, highly polished and smooth reflecting surface created using plain glass sheet. And silver coating on one side. So plain glass sheet on one side, and okay, let me move this here. So, and silver coating on the other. So take note of that. So the next concept that will be defined, please take note, is the incident ray. And this is the light ray which strikes or hits a reflecting surface, e.g., a plane mirror. Please focus in class and take note. These are important examination concepts. So light ray which strikes or hits a reflecting surface, e.g., plane mirror. Take note of that. And then we'll go to the next concept, which is the reflected ray. I will say this is the light ray obtained after reflection occurs from a surface. In the same medium where incident ray is traveling. So please take note of that. Another concept we have that is pertinent to this topic is the angle of incidence. You see some of these concepts right here. This is the plane mirror. Set to that. This particular one, the plane mirror. This is the reflected, this is the incident ray. That particular guy, this particular one, I repeat, incident ray. You can see that. Please take note of that. This is the reflected ray. See that? This guy right here. So please take note of that. And now we are going to the angle of incidence. That's this guy, I. So please, let's talk about it. Let's define it and establish it. Angle of incidence. I want to make sure you are following. Angle of what? Incidence. So the angle of incidence is the angle which the incident ray, please focus, make sure you are paying attention. These are important examination concepts. The angle which the incident ray makes with the normal. I explained what the normal is. At the point of incidence. So let me quickly go and tell you where the point of incidence. This is the point of incidence, this particular point. That's the point of incidence. Take note of that. Let me use another color to quickly color that place and put some red there. This is the point of incidence. You got the concept. Very important. So the angle which the incident ray makes with the normal at the point of incidence, that is called the angle of incidence. And it is denoted by I, the letter I, small letter I. Excuse me. Another important concept to take note of is the angle of reflection. The angle of reflection is the angle which the reflected ray makes with the normal at the point of incidence. Take note of that. It is normally denoted by a small letter r. This is by. Please take note of that. By small letter r. And so we see all of those concepts in the diagram that we have established before. Take note. So let's go over to, as per reflection of light, there are some other important things I will establish as I ask questions. I ask questions and answer them. So catch your breath as we go on in this class. Make sure that you're listening attentively and that you are taking notes. Now, I will establish that there is something called regular reflection. This occurs on smooth and polished surfaces rather. Smooth and polished surfaces, such as a plane mirror, this is plain. Make sure you write well. It's also important yardstick for excelling in your exam. Plane mirror. Take note of that. Why irregular reflection is the kind of reflection that occurs, please pay attention and focus, that occurs on a rough surface, such as, can say a piece of paper, surfaces that are not mirrors. You know, for example, you have a plain sheet of paper, it's a sheet of paper. So please take note of that. Let's now quickly go to another subtopic, which is the laws of reflection. The laws of reflection of light. Please, you don't have time, you don't have the luxury of time for jokes. Make sure that you are paying attention. The first law, the angle of incidence is equal to the angle of reflection. So as to make sure that you are focused in this physics class, I want to tell you that most of the things that you have been taught, everything, not even most, applies everywhere in the world. America, Europe, Asia, wherever, Africa, it applies. These are standardized, physics classes. So please pay rapt attention and make sure that you get the important points for you to excel in your exams. The first law is the angle of incidence is equal to the angle of reflection. What does that mean? everywhere reflection occurs on a plane surface. This particular I that you see right here must be equal to R in all cases. It is a law. Take note of it. The second law, the incident ray, the reflected ray, and the normal at the point of incidence. At the point of incidence, they all lie on the same plane. So the point here is the incident ray, the reflected ray, and the normal all lie on the same plane, which is this plane. So that's another law that you have to take note of. You see the way I explained it? Very important, so that you don't forget it easily. Please take note of that. Catch a breath or two. Take some notes. Make sure that you are understanding. Now, a wonderful question. If a question says, we have a case. Let me take an example. Write down. The figure below shows incident ray A, B, and normal C, B on a plane, mirror to be precise. It says the angle which the incident ray AB makes with mirror, or let me say with the mirror, with the mirror is 40 degrees. We're encouraged to find the angle of incidence. Like I said, pay attention. The importance of a question is that you get the main idea so that you can utilize that idea to solve another problem that is different. So let's see the main ideas here. Find the angle of incidence. That's not the only question. The B part says, draw the reflected ray and then find the angle between the incident and reflected rays. So that is the question. The question gave you this figure. Excuse me, let me draw that properly. So the question gave you this figure. We have incident ray rather, AB, and then the normal, this is normal CB, AB. Yeah, so, and in the question, we're not given the reflected ray because we're asked to draw it. So take note of that. So this is what we have in the question. And it told us that the angle which the incident ray makes with the mirror, this is the mirror in question. So let me point at it. It's another color. This is the mirror. And this is the incident ray. We're told that the angle that this incident ray makes with the mirror is 40. That means this place is 40. That's the angle it makes with the mirror. We're not told to find the angle of incidence. Normally in our regular, by our regular knowledge, by the knowledge I've established to you so far in this class, where is the angle of incidence? Where is that regular point that we normally call I? Oh, you are very brilliant. You got it. If you thought that it is this point, you are right. That is this particular angle, which we normally call I. That is the angle of incidence. Now, you will discover that we can easily find that angle by subtracting 40 from 90. Why? Excuse me. Because we know that CB makes an angle of 90 every time with the mirror. You know what CB is? The normal. This guy is the normal. And why we call it normal is because it makes an angle of 90 every time with the mirror. So since it makes an angle of 90 with the mirror, it means this entire angle here is 90. You get the idea? So please pay attention. If the entire angle there is 90, we can easily get I. We know that I plus 40 will be equal to what? 90. So we can easily get I by saying what? 90 minus 40. Very, very important straight idea. Take note of that. Now, the next part of the question says, draw the reflected ray and then find the angle between the incident and reflected ray. That is a very brilliant question. Now, it says to draw the reflected ray. From what I can see up there, let me zoom out. I can draw something like this. Let me straighten. Yeah. I can draw this, my normal. Yeah. So I know that this is my incident. This guy is my incident. This is my normal. So my reflected ray has to go this way. And so I know that this point here is 50. And so this point will also be 50 based on the first law, I equal to R. Take note of that. So this is my reflected ray now. Reflected ray. Take note of that. So having noted that, the next part of the question now says, find the angle between the incident and reflected rays. This is the incident ray. Don't forget that. And this is the reflected ray. We're asked to find the angle between them. Oh, definitely you are all geniuses. So clearly, just by looking at it, the angle, the total angle here is what? Angle between incident ray and reflected ray, as we can see, is going to be 50 plus 50. Are you there? Please, no jokes. Focus and, digest this thing. It's 50 plus 50 because that's the angle between the incident ray now and the reflected one. Take note of that. And that gives you 100. That is this particular angle. You see the total right here between the incident and reflected. So take some minutes, catch your breath, catch your breath. We are doing very well. Catch your breath. We will now go to establish some concepts. Let's talk about the characteristics of the image formed by a plane mirror. Formed by a plane mirror. So number one, the image is erect. or we say upright. Number two, the image is virtual. Hello, my students. This question is a major exam question. The characteristics of image formed by a plane mirror. The image is erect, the image is virtual, so please take note, don't play in class. The image formed is of the same size as the object. And then we say the image is situated at same perpendicular distance behind the mirror as the object in front of it. And that one we can add is the fact that it is laterally inverted. I'm going to explain this the fourth and the fifth point. And then before I explain the second point, I will use an explanation of, what real image is and what virtual image is to explain the second point. So these are the points we have so far. One, I will give you 5 very soon. I'll give you the 5th one rather very soon. So what we have as the 5th one is that it is laterally inverted. Laterally inverted. So let me quickly tell you what the 4th point and the 5th point mean. If you have, for instance, explanation, let me call this explanation. We have a plane mirror. Let's say you stand in front of a plane mirror now. Or let's say I put a letter P in front of a plane mirror. What we see on the other side is same size, but the idea that we are seeing something like this is called lateral inversion. You can see that it is erect, it's standing straight. I mean, standing upright, just like this one. Just like this one. This one too is standing. It's erect. But it's laterally inverted. That is, if you have F, you are having something like this. So you get the idea as the result. So that's lateral inversion. Then the other idea that that's the same perpendicular distance behind the mirror. This is where you put it. This is where you put this stuff. And you look at this distance. Whatever distance you have in front of the mirror will also be equal to the distance that you have here. That is the red thing that see will be equal to the green distance. Take note of that. That's what they mean by point 4, where they say image is situated at a same perpendicular distance behind the mirror as the object in front of it. Then we have seen what lateral inversion is like. Then we see that it's also erect. It's standing upright. That is, if you put F, you will see something else that's standing the same way, but laterally inverted, having the same distance in front of the mirror and then behind the mirror. Then the idea of virtual, before I talk about virtual, I would love to talk about the difference between real and virtual images. And in that difference, you will now see what a real image is and what a virtual image is. Real image. Virtual image. Let's establish that difference. I hope you are paying attention in this class. A real image is the one formed due to actual, so this can serve as a definition, intersection of reflected rays. While a virtual is formed due to, so whenever you want to define them, you can just use the differences, individually. Yeah. So is formed, this one is formed when, let me use when. So it is formed when the reflected rays meet as they are produced, backwards. So virtual image formed when the reflected ray meet as they are produced backwards. So this one is just formed by the intersection of the reflected rays. That is, that's real image. Then another difference, point 2, is that this one can be formed, the real image can be formed, it can be formed on a screen. This one, it cannot be obtained on a screen. And the third one is, this one, it is inverted. This one, it is erect. So when we say inverted and erect, this one is inverted with respect to object. It is erect with respect to the object. Take note of this point. So far, this is what we have considered in the class. And I want you to catch a breath while I get some questions, some other important questions ready. We ruminate over the ideas that we've established on this very topic called the reflection of light, as I make ready some other concepts that I didn't fit for your knowledge in this class. Please, no jokes. Most of the points discussed in class so far are most essentially important as you deal with other problems. You use these ideas and establish the important concept. Like I said, from these differences, you can easily create your definitions for real images and then, virtual images. Let me quickly create that definition. So I can say, if I want to define a real image now, real image, excuse me. So the real image can be defined as, let me write it out. This is the image. Sorry, excuse me. I seem to have a runny nose. This is the image formed by actual intersection of reflected rays. It is inverted and can be obtained on a screen. Straightforward. That's it. So if we were to go into the definition of a virtual image, you have the idea ready as well. And that is, the virtual image is the image formed. Can go back when reflected rays meet as they are produced backward. I say it is erect and cannot be obtained on a screen. Kindly take note of that. Thank you. Now let's start dealing with problems. We'll deal with problems as it relates to your exam. And then we'll see how far we can go in this class with those problems. Take note of that. Are you ready? Yes. Now, let me take you right into it. See the first problem. Excuse me. It says, according to the law of reflection, which of the following is correct? Option A, I over R equal to constant. Option B, sine I over sine R equal to constant. Option C, I plus R equal to constant. Option D, I equal to R. Students, what is the correct answer based on this class you have just taken? You are right. I equal to R. It is one of the laws of reflection. We established that. So let's not waste time. Let's quickly move to the next question. And the next question says, oh, let me switch my pen. The image formed by a plane mirror has the following characteristics. Option A, erect and diminished. Option B, erect and enlarged. Option C, inverted, and same size. Option D, erect and same size. These are the options. Please think about it very well before you pick your answer. Erect and diminished. When I was explaining just now, I never talked about diminished. There's nothing like diminished in a plane mirror. So option A is out of the game. Erect and enlarged. I did not talk about enlarged as I was explaining concept. So option B is out of the way. Option C, inverted and same size. I did not talk about inverted. I only talked about laterally inverted. They are two different things. So if you don't see laterally inverted, it's not correct. But I talked about erect and same size. If you go back, let's go back to that portion of the note. Characteristics. We see right here the image is erect, and we see that it is the same size. So that makes our correct option in this problem to be option D. Please take note of that. That's how you utilize your knowledge. We'll move straight into the next problem. Problem 3, the image formed excuse me, let me rub this off. The image formed by a plane mirror. By plane mirror is option A, real. Option B, virtual. Option C, virtual with lateral inversion. D, real with lateral inversion. So the idea here is pick the best option that corresponds to the image formed by a plane mirror. Is it real? No. We remember quite well in our characteristics, we see that it is virtual. So it is not real. It is what? Virtual. But it is not only virtual, it is also virtual with lateral inversion. So the best option to pick here is option C. Option C. Virtual with lateral inversion. Let's quickly continue in this set of problems as we go to the next one. And that next problem says the incident ray and the reflected ray from a mirror are mutually perpendicular to each other. Find the angle of incidence. This is a very important question. The incident ray and the reflected ray from a mirror are mutually perpendicular to each other. The meaning of that, if I put that in a diagram, I'll say, okay, the incident ray and the reflected ray, these two of them, they are mutually perpendicular. That is, the angle between them is 90. That's what they mean by they are mutually perpendicular to each other. This is, let's say this is the reflected ray now. Sorry, incident ray, and this is the reflected ray. So I'm using like the denotation of RRIR. So this is the incident ray, reflected ray. We are told that they have an angle. They are mutually perpendicular to each other. See this concept here? It means that the angle between them, this angle right here, is 90. The question can come in another way and tell you that the angle between them, it will state it and say maybe it's 125. So in that case, this particular place becomes what? 125. But at least for now, we know that they said they are mutually perpendicular, and that place stays as what? 90. But what is the goal of the question? The question says we should find the angle of incidence. We know that angle of incidence is the one made between the incident ray and the normal. We have established that. So let's draw our normal here. Our normal comes down here straight between them. And what we're looking for now is I, the angle of incidence. Because we know that that's the angle made between this guy and the normal. So this one and the normal. So we want to find I. How do we find I? Just go to the first law of reflection, which says that what? I equal to R. The incident ray equal to reflected ray. And how do we use that here? We know that this other part is R. And we know clearly they have given us that the angle between the entire angle from here to here is what? 90. So we know that I plus R must give us what? 90. But we know that I equal to R. So we can replace R here with what? I. Replace it with I. And the reason for doing that is because based on the first law of reflection. You see how we solve problems? First law of reflection. So we have I plus I now equal to what? 90 degrees. And so that gives us 2I equal to what? 90 degrees. And that gives us I to be what? 90 divided by 2, which gives us what? 45 degrees. We have solved that problem. We have solved what? That problem. And just in case the same question asks you the angle of reflection, you don't need to stress yourself. We know that I equal to R. So R will also be equal to what? 45. So both I and R are what? Equal to 45. I equal to 45. And since R equal to I, R is equal to 45 as well. And we have solved that problem. So take note of that. But this question only asks you to find I, and we have found that. So but I was just dealing with this just in case. It asks you to find, R. Can easily just straightforward. Take note of problems like this. Once again, this is the reflection of, excuse me, please. This is the reflection of light. And I hope that you are paying attention in class. We'll go to the next problem. That was problem 4. We'll go to problem 5. And this is physics that applies everywhere in the world. As I'm teaching you, this is exactly how it is taught elsewhere. And this is standardized. So pay attention and make sure that you excel in your exams. A man standing in front of a plain mirror, finds his image at a distance 6 meters from himself. What is the distance of the man from the mirror? Interesting problem. So take note of that. A man, I can quickly paint that picture. A man standing in front of a plain mirror finds his image at a distance. Let's say this is his image. And one of the ways to show lateral inversion, if I put maybe red here and I put green here, you should know that the image will show green before red. That's how to show lateral inversion, first of all, for a plain mirror. So that's just the idea. Then it says, no, the question did not ask you to show that. I'm just shipping that in so that you understand the concept of lateral inversion. And let's just continue the question. This is the man. This is his image. Man, image. So they said the image is at 6 centimeters. From where? From himself. So, as me, they said the image is 6, it's not 6 centimeters, 6 meters rather. It says it's 6 meters from himself. That is, from here to the image is 6 meters. As me, they said it was 6 meters from the mirror. It would have been from here to here. So please pay attention to it. You see, this is why you are doing English language classes too, so that you are able to use your understanding. So you must know English. You are looking at it. His image is at a distance of 6 meters from himself. That is from himself. This is himself right here. From himself to the image. 6 what? Meter. So it didn't say that it is 6 meters from the mirror. So take note that one, that's not it. It's 6 meters from him what? Himself. Then I ask you, what is the distance of the man from the mirror? They're now asking you, what is the distance of the man from the mirror? This is the man. The man right here. What is the distance of that man from the mirror? We're asking us to find X. We know that for a plain mirror, we have said they are same. We established this as we are teaching, where we said same, you see it, same distance. We said this place, they were the same distance. We mentioned it, this particular distance, we mentioned it. That was when I was explaining 0.4 and 0.5. We mentioned that these distances are the same. So we have established same distance and same size before. So look at this. In this question now, we utilize that idea. we say, okay, we have X here. But what if we call this other one Y? So we know that what? We know that it's same distance. And that means that X plus Y equal to 6. But we can replace Y with X. Our reason for doing that is same distance in plane mirrors. I've already established that rule. You are following, I believe so. Yeah, same distance. So we now have X plus X will give you what? 6. And so 2X will be equal to what? 6. And X will be what? 6 divided by 2. And that will be what? 3. So the X we are looking for, which is the distance between the man and the mirror, is definitely the distance between the man. Oh, let me not do that. Let me write it in full. Between, and please take note of that. I know some of you chat a lot, so please, and you should not be chatting. You should not be chatting in school. You should focus now on your studies so that you will ascend greater heights in life. So leave chatting behind now. Focus on excelling at your studies. So what I wanted to just ship in from there is, please take note of the way you use shorthand. Don't use this for between. It will make you to fail in the exam. So please take note of that. So the distance between the man and the mirror is 3 meters. Another important thing, this is a wrong kind of solve. If you just put 3, that's 3 what? Meter. Take note of all these things. We have solved an important problem there, and I hope that as you take the note, you can go and read it at home and ruminate over it. The next problem, which is problem 6. Problem 6 says, an insect is seated in front of a plane mirror at a distance 1 meter from it. Question A, where is the image of the insect? Of the insect found. Question B, what is the distance between the insect and its image? Take note of the question. Where is the image of the insect found? And then what is the distance between the insect and the image? Now, let's paint a diagrammatic picture of this again. An insect is sitting in front of, let's say this is the insect. So an insect is sitting in front of a plane mirror. This is the insect right here. 1 meter from it. They are telling us that the distance from the insect to the mirror is 1 meter. They are now asking us that where is the image of the insect from? Of course, we know that the image will be somewhere here. You see, I just used the rough idea of lateral inversion to form the image. So I know that the insect will be somewhere here, but I can easily guess that the insect will also be 1 meter from the mirror because we have been told that same distance. So the answer to A is what? 1 meter behind the mirror. Very straightforward answer. Then the B part, What is the distance between the insect and the image? That's the total distance now. This is the insect. We know that this is the insect right here. Insect, and this is the image right here. So they're asking us for the total distance now from insect to image. So since we know that here is this part is 1 and this part is 1, what will be the total? The total will be what? 2, right? So we have our answer to be the distance between the insect and its image is going to be 2 meters. So please take note of that. 2 what? Meter. Please focus on the class. Don't let anything distract you. 2 meters. I will be taking what I would call, let me take, should I take 1 more question or 2 more questions? Let's do this. Okay. Let me take, I might take 2 more. Okay. So that was question number 6. Let's take 7. And then let's see how we go from there. An object is kept at 60 centimeters in front of a plane mirror. If the mirror is now moved 25 centimeters away from the object, how does the image shift from its previous position? Let's critically analyze this question. First of all, an object is kept at 60 centimeters in front of a plane mirror. So we have an object. Let's say this is the object, a box kept 60 centimeters in front. 60 centimeters in front of a plane mirror. If the mirror is now moved 25 centimeters away from the object. Now, we know that first of all, an object 60 centimeters in front of a plane mirror will produce an image that will also be what? 60 centimeters behind. Do you see that? We know that we know this one now by standard. We know this one. It's not something that you start explaining as a big deal. No. You should know this one by now. That okay, once you have for a plane mirror, you have the object in this position, you should have the image in this position. So this is what we have for now. In essence, if the mirror is now moved 25 centimeters away from the object. Now, if we now move this mirror now from this point where it is, we move it 25 centimeters away from the object. So when we say away from the object, we mean in this direction. So this is the new position of the mirror. So, and the meaning of that is now the new distance between the object and the mirror is 60 plus 25. So the new distance is now what? 85. And what does that mean for the new distance of the image? We know that since the new object distance is 85, and object distance is always equal to image distance. Is always equal to image distance. That's what we've been doing since. So you know that since the new one is 85, it means the mirror is now in this position, right? It means the new object 2 will now be what? 85. That's just a rule. So our answer to this question is definitely going to be what? 85 centimeter, the new distance. So new distance of object, sorry, of image rather, is equal to what? 85 centimeter. Take note of that. Let's go straight into the next question, and which might be the final question for this class. So that is question number 8. In subsequent classes on reflection, we'll be solving further problems. So, but for now, the main ideas have been gotten, and just by rehearsing and revising them and testing out yourselves on questions by your own personal reading, you get to expand on this knowledge. So here is the question number 8. An optician, while testing the eyes of a patient, keeps a chart of letters 3 meters behind the patient and asks him to see the letters on the image of the chart formed in a plain mirror kept at a distance 2 meters in front of him. Don't worry, we'll analyze the question and understand it and solve it. How far away is the chart seen by the patient? Let's analyze the question right now. An optician, while testing the eyes of a patient, he sees, or he keeps a chart of letters 3 meters behind the patient. Let's say this is the patient now, and this is his back. This is his back, of course. So we have identified where the back of the patient is. And so let's say we keep the letters here. You know, all of you who have gone for eye test. I'm also a 4-eye person. So I can tell you experientially about this. So they keep a chart behind him. But here we are told that the chart is 3 meters behind him. And then they ask him to see the letters on the image of the chart. Let's say we have K here, I here, G here on the chart. And then the doctor who is in front of him says, okay, can you see those letters? They place a mirror somewhere here. Place a plain mirror somewhere here in front. And they're asking him to look into the mirror to see if he can see those letters. Let me put the direction of his looking. He's looking into this mirror to see if he can see it's a plain mirror, so I will try to laterally invert too. So that is it. They're asking him, oh, look into the mirror and see the image, the letters of the image of the chart formed in the plain mirror, kept at a distance of, so they are telling us the distance of the mirror now. They kept the mirror 2 meters in front of the guy. So they're asking us, how far away is the chart seen by the patient? How far away is the chart seen by the patient? The idea is that now we have this thing to be 3 meters? This is a very strategic question. You have the distance between the man and the mirror, 2 meters. We have the distance between the man and the shaft, behind him. Behind him. This distance is what? 3 meters. Now, basically, we are practically saying the distance between the shaft and the mirror. This is the shaft now. And this is the mirror. So the distance between the shaft and the mirror, see it, is what? 5 what? Meter. The final image will now be formed on this mirror at a distance of 5 plus 2. Let me explain that. Let me write out some of the concepts. Distance between man and shaft is 3 meters. The distance between the man and mirror is 2 meters. So it's very easy to say the distance between the shaft and mirror. Distance between the shaft and mirror now will be 5. Between the shaft, excuse me, and the mirror. It's going to be what? 3 plus 2. Excuse me. Excuse me. 3 plus 2, which is what? 5 meters. And so if you don't want to get the final image rather, on the mirror, we're told that the mirror is at the mirror is at 2 meters from the man. Yeah. This man is going to see, is going to first of all see, we have to incorporate is 3 meters. We have to incorporate the 2 meters. And then we talk about another 2 meters. Let me do something here. This is the mirror. I'm going to have the man will see himself here. Then you will see the shaft here. Oh, that would have been a better explanation. Let me help you. So please pay attention. Let me help you. Let me erase this particular something. Yeah. Let me just put, you know what I've been putting for the mirror before? It's just a straight line. So behind the mirror, the man will see himself at 2 meters because that's just a reflection of where he is right here. You have him right here. He will see himself 2 meters here. But he will not see this guy here. The entire stuff here is what? 5, Abby. You will also see the shaft. Let me put the lateral inversion idea. So you see the shaft with the words on it. I didn't draw that clearly, but that's fine. Just know that this is an indication of the shaft. So he's going to see the shaft right there. So, but we know that the distance between the man and the shaft is 3 meters. So we know that right here we have another 5 meters. So get the idea. This is the mirror. This is the man. This is the shaft. So behind the mirror, we have the man again and the shaft. So this 2 meters is based on what we know. This is 2 meters. This is also going to be 2 meters. This 3 meters is also based on what we know. The distance between the man and the image here is 3 meters. So it's also going to be the same thing right here, 3 meters. So for now, the question asks us to find how far away is the shaft seen, that is the image of the shaft, by the patient. Now, they're asking us the distance between the man in front of the mirror, this guy, and this shaft. What's that distance? What does it look like? That looks like, so between the, let's write that distance down. You can add that distance. Let me clean that one that I wrote before. Distance between man and image. Now, just pay attention. Equal to what? This is man. Let me point at him again. This is him. See where my arrow is. This is him. And this is the image. Let me use green. I'm pointing at it. This is the image. So we can see that that would be somewhere from here to here. And we start, that's made up of 2 plus 2 plus 3. Clearly. You can see that. From this point where the man is to this point where the image is. 2, that's from here to here, plus another 2 from here to here, plus 3 from here to here. So that gives us 2 plus 2 plus 3. That gives us 7 meters. So take note. The simple idea is, I'll repeat it just to clarify. This is where the shaft is. Initially, this is where the man was. They told us that it is 3 meters behind the man. And they told us that there is a mirror and the man is 2 meters in front of the mirror. They said it in the question. In front of him, 2 meters in front of him. So now they're asking us to find the distance between the man and the image of the shaft seen. This is where the shaft will be formed. We know that since this place is 2 meters in front of the mirror, there will be an image of the man that is also what? 2 meters. That's a normal rule for plane mirror. Then we know that the shaft will also be behind the man at the same distance where we have what? 3 meters here too. So we know that, yeah, 5, 5 is a settled idea. But we know that the question is now asking us what is the distance between the man and the image of the shaft. So that means we're not streaming it down to here to here. So we are cutting out that 3. So what we're left with is 2 plus 2 plus 3. That gives us 7 meters. I just reiterated that for you to understand the concept more. Congratulations on attending this class, and I believe it has added to your knowledge significantly. We'll see you in our next class, and make sure you keep working hard.